Hello everyone, today I'm going to talk you through PAG8.1, an investigation into the water potential of potato. So following our procedure, the first step that we have to take is a serial dilution. So we'll need to prepare 0.4, 0.2 and 0.1 mole per decimetre cubed using our 0.8 mole per decimetre cubed sucrose solution and distilled water. Now in your PAG instructions you are given a diagram to help you with this, and you must make sure that you write in on that table the dilution that you are doing. It tells us that for our 0.4, 0.2 and 0.1 we are going to be adding 20 centimetres cubed of distilled water to each beaker. Now as we are diluting them by half each time, that means we'll need 20 centimetres cubed of the 0.8. We add 20 centimetres cubed of distilled water to give us our 0.4 moles per decimetre cubed. One of the pieces of equipment that we're given is a syringe that goes up to 20 millilitres or 20 centimetres cubed, so we will use this to measure out into each of our beakers. So I take 20 centimetres cubed of the 0.8 and I will put that into the first beaker of 0.8. For my 0.4 dilution, I have 20 centimetres cubed of the 0.8, and then I will dilute that down with 20 centimetres cubed of the distilled water. So this is 20 of 0.8. And then I will add to that 20 of distilled water using a different syringe this time to avoid any extra dilution. So what we're now going to do is take 20 from this 0.4 beaker . And we're going to transfer that across to our 0.2 beaker, and then to dilute that down to 0.2 I'm going to add 20 of distilled water. And then exactly the same for our final one. I'm going to take 20 from the 0.2. I'm going to move that across into our 0.1 beaker. And I'm going to add 20 of distilled water. Now there is more in the 0.1 beaker than in the others. That's okay, because on the next step they'll all be evened out. The next step asks us to label 6 boiling tubes with water and then 0.1, 0.2, 0.4, 0.8 and 1.0 moles per decimetre cubed for the sucrose solutions. It asks us to place 20 centimetres cubed of water or sucrose solutions into the boiling tubes. So using a fresh syringe, we will take 20 centimetres cubed or 20 millilitres of distilled water and put that into the distilled water boiling tube. I will take 20 centimetres cubed of the 0.1. This will leave some behind in the beaker, into the 0.1 boiling tube. We'll then take our 0.2 up to 20 centimetres cubed and put that into our 0.2 boiling tube. We'll do the same for 0.4. 0.8 and for our 1.0 mole per decimetre cubed, this wasn't part of our serial dilution, so we don't need those beakers anymore. You will have been provided with a 1 mole of sucrose, and so using a syringe will measure out 20 of that separately. And that will go into the 1.0 boiling tube. The next step of our instruction is to draw a results table for our results. It tells us in the instructions exactly what needs to be included. So it asks for the sucrose concentrations. So we need to make sure that we have also included water in that at the top, the initial mass, final mass, and it wants a percentage change in mass. So you can include a change in mass column, or you can go straight to percentage change in mass. You must make sure that the units are included in the heading and that they are not in the body of the table, and that all of the columns, everything is written to the same decimal places. So we need to make sure that all of our potato pieces are the same size, so we use a white tile for this and a sharp knife. It specifies 40 millimeters or 4 centimeters long. So we put our potato onto the white tile and we use a ruler to measure the length of the potato and make sure that we are cutting a smooth edge to measure from, and we measure across 4 centimeters or 40 millimeters, and we do another cut there so that all our potato pieces will be the same length. So we'll need to do that for all 6 potato pieces that we're going to be using in this investigation. What we are left with now then are 6 potato pieces that are all the same size, and for each of those potato pieces we're going to need to roll it on a paper towel 3 times to ensure that all of the excess water on the outside has been taken off so that it cannot impact our results. So all of the pieces get rolled down a paper towel to make sure that there's no excess water on the outside. Been rolled across the paper towel, so we bring in the balance, we make sure that our balance is on, and then we press the tare or 0 button to ensure that we're getting a 0 reading. We put each potato on in turn and make sure that we take a note of their initial mass, ensuring that all the decimal places are the same. It is then worth putting that potato chip next to the tube that it will go in so that you remember which potato needs to go into each of the boiling tubes. So this is our third one at 0.2. Then do our 0.4. If it moves away from 0, make sure to re-tare or 0 in the middle so that you have as accurate readings as possible for the mass of each of the chips. And then our final one that will go in 1.0. So your table of results should now have an initial mass all filled in for each of the potato chips. What we now have are our 6 tubes that all have their potato piece inside of them. We put a bung in the top of each tube. This is to make sure that the volume of liquid stays the same and that none of it will evaporate away whilst we leave them. We need to leave them in the tubes for at least 1 hour. So we'll start a stop clock to track that time. So our potatoes have now been in solution for at least an hour. and we need to take them out in the order that they went in. So for mine, that was water went in first all the way through to the 1.0 moles per decimetre cube, which went in last. So when we are taking them out, we will be using forceps to get them out of the tube. We will then need to make sure that we once again roll across our paper towel to remove any of the excess liquid that might be on the outside, and we will then get a final mass. Remember that you may need to re-tear or zero the balance, and then we will write our new mass into the table under the final mass column, taking care to use an appropriate number of decimal places. So that's our water. Take out 0.1. Zero 0.2, roll on our paper towel, .4, .8, and finally 1.0. We should now have in our results table a final set of results. So we have each of our concentrations, initial mass, final mass. We can now calculate our change in mass and our percentage change in mass. Once you have collected all your results, you need to make sure that you complete your full results table so that you have your percentage change in mass, and then you will complete a graph. So you will then draw a graph of your results with an appropriate line of best fit. The final step is to calculate your osmotic potential of the potato, and that is where your line of best fit crosses the x-axis. So that would be here. So you find your osmotic potential for your individual potatoes.